So at this point, it's not really news to anybody that Arshad Nadeem just won the gold medal at the Olympics for javelin throwing in this year, Paris 2024. But I've seen on social media there are a lot of confused explanations going around as to what's the physics, what's the science behind this stuff. So I thought I should just step in and clear all of this stuff up. Let's just start with what we actually know. So what we do know is that the javelin was thrown at 110 kilometers per hour at an angle of 31.76 degrees with the horizontal. This is official data released by Olympics itself. And obviously this very memorable number is the distance that this javelin covered in landing to this final spot. So this is stuff that we already know. But what else do we know? Let's for a second ignore this 92.97 figure and let's try to calculate it and see how accurate our calculations are. So I did some thinking and I realized that we needed the time for which the javelin was in the air. Unfortunately, this was not released by the Olympics committee itself, so I had to do some digging. What I did was I screen recorded the live video and I used some time frames to find out exactly when the javelin left Arshad's hand and when it landed. And using those time differences, I found that it was in the air for approximately 4.5 seconds. So the first thing that we will see here is that this is a case of what we would call projectile motion, because there is velocities in two perpendicular directions. That's what we're going to do, is that we're going to break these up, and there is good reason for doing so as well. Some basic trigonometry shows that this one would be cos, this one would be sine. Also, I see that my velocity here is in a non-SI unit. Let's go ahead and correct that. Just by dividing by 3.6, I have my speed now in meters per second, and this is going to be 30.6 meters per second. So now, because we have to find out the range which is covered, and now we already know the time as well, which is 4.5 seconds, we need to find out how much distance the projectile actually covers. So for that, we need to focus on the horizontal aspect of things, because we are also interested in the horizontal distance. The vertical component here does experience some acceleration because there's obviously the weight of the projectile which is pulling it down. However, horizontally there is no such force, and consequently there is no acceleration as well. Now we need to find the distance. The equation of motion that comes to mind is the second one, which is this: S equals ut plus half at square. But because there is no acceleration, acceleration is 0, hence 0 multiplied by anything is also 0. So this entire term goes away, and what we have is this: S equals to ut, which some of you might also recognize as just a rearranged form of the speed formula. Distance equals speed times time, which is just another way of saying that speed equals to distance over time. So now for the distance, we just need the horizontal component of the velocity, which was 30.6 cos 31.76, which turns out to be 26.0, and multiply this by the time of flight, which was 4.5 seconds. So this gives us 117 meters, correct to 3SF. Obviously this would have been even more ridiculous of a record, but there are reasons for why this is actually more than 92.97. And one of the main reasons that anybody with some basic knowledge of physics can indicate is the idea that there is no air resistance involved in our calculations, which would have been there in reality. Right now, this beautiful parabola that I drew, this is not how actually the journey would have looked like. It would have probably been more of something like this. It would not have been very symmetric because of air resistance. This is one reason. But actually there are a lot of other aerodynamic factors which also affect the flight of the javelin. One of these factors which is very important is something called the angle of attack. Right now at this point we assume that whatever angle the javelin makes with the horizontal is also the angle of the velocity. This is not true. At some path in the middle, the javelin would also be like this with some angle with this path. This angle is called the angle of attack. We did not include this in our calculations at all. So this is a very simplistic analysis. The actual physics is much more complicated than this, also takes into account a lot of other factors such as lift and air resistance and many more. But this is some of our analysis that we did. So I hope you guys found this explanation cool. Congratulations again to Arshad Nadeem for making Pakistan proud.